Okay, so let's look at our worksheet we have for today. We have to graph some polynomial functions. All of these functions are written in factor form because that allows us to quickly find the x-intercepts. And remember, x-intercepts are opposites of what's inside each of these parentheses. So in this case, the x-intercepts are -1, +2, and +3. Now, we also have to pay attention whether any of those x-intercepts are repeating more than once. And if you look over here, you will see that x plus 1 is repeated twice. And this is really important because that means, so this one repeats twice. This means that where the graph of this function is not going to cross x-axis at -1. It's going to touch the x-axis and then go back in the opposite direction. And this happens anytime the x-intercept repeats an even number of times. So if the multiplicity is an even number, it will not cross the x-axis. Okay. Now for the degree, we're going to look at our exponents. So in the first parentheses, I have x to the second, and the second parentheses, I have x. And in the last parentheses, I have x. Altogether, that's 4x's. So degree is 4. I don't have any coefficient in front, so my leading coefficient is less than 0. I'm sorry, not less than 0, greater than 0. Okay. So that should help us figure out the end behavior. And I'm going to give you a little cheat sheet. So if I have an even, and positive function, I can think of x to the second, which looks like this. If I have even negative function, then it would look like -x², which opens down. Okay. If I have odd positive, I can think of x³, which looks like this. And if I have odd negative, I can think of -x³, which will face in the opposite direction like this. Okay, so this should help me figure out what the end behavior is. So in our case right here, we have an even and positive, okay, which means it will look, the ends of it are gonna look like x². So on the left side, it's gonna go up, and on the right side, it will go up. Okay, so the graph would look like this, except we don't know what this middle part looks like because that will be determined by what happens with our x-intercepts. So to plot this function, I'm going to plot my x-intercepts. Okay, so we have a -1, 2, and 3. I'm going to put points at all our intercepts so we know what they are. I'm sorry. And we also know that this function goes up at both ends, right? So we know that at -1, this graph is not going to go through the x-axis. Okay? Remember, if the multiplicity is even, the graph will not go to the axis. It's going to touch it and go back in the same direction as it came from. So in our case, at -1, we're going to bounce back up, and then we're going to turn and go back through 2, turn again and go back through 3. Okay, so notice at 2 and 3 we went through because the x-intercepts did not repeat, but at -1 we did not go through the x-axis because the x-intercept was repeated twice. And anytime you have a 0 that repeats an even number of times, this is what happens. We're going to curve the graph up like this. Okay, so we're going to go to question 3 now. Okay, so same deal. Okay, we're going to look at our equation to answer all the questions. Okay, so we know that the degree will have x to the third in the first parentheses and x to the second in the second parentheses, which means the total degree is 5, which is odd. Okay, the leading coefficient again is positive, so a is greater than 0, which is positive. So if I look at the function as odd and positive, I would look at this x to the third power, right? Which looks like this. So we know that our end behavior is gonna go like this. Okay, so left side is gonna be down, facing down, and right side is gonna face up. Okay, and the x-intercept in our case are positive 1, which repeats 3 times, and negative 4, which repeat twice. Okay, so I am going to plot my x-intercepts at negative 4 and 1. Okay, we know that the left side, the graph is going down, facing down. On the right side is facing up. Okay, and if I look at our multiplicity, how many times each of those zeros repeats, you can see that negative 4 repeats twice, which is an even number. So at negative 4, we are not going to go through the x-axis. We're going to turn at x-axis. So we're going to have like a turning point there. And we're going to go back down, and then we're going to turn again and go to 1. So this is the graph of function number 3. Okay, all right, let's look on the next page. Let's go to question 1. So now we are given the graphs, and we are asked to answer a question about each of those functions. So if I look at my function number 1, okay, I know that both ends face in the same direction. And if they face in the same direction, then the function is even. Okay. Now, since the function is facing down, think of this negative x squared. This looks like negative x squared, right? It looks like this. Since the function is facing down, it has negative leading coefficient. The end behavior. Now we're going to use the proper mathematical terminology. So instead of saying left, I'm going to say x that is near negative infinity. And instead of saying right, we're going to say x at positive infinity. So at negative infinity, so if I go all the way to the left, this graph is facing down, right? And down, if I look down on my coordinate plane, I have really big negative numbers. I'm going to say that this function, f of x, is going to negative infinity. If I look on the right side of my graph, right, if I go to the really big axis, the value of the function also is going to be a really big negative number because it's facing down. So I'm going to write that f of x, again, is equal to negative 8. Now, how many intercepts we have? The intercepts are right here. There are 2 intercepts. Okay, let's look at question number 2. Okay, so same thing. Both ends facing up. Both ends facing up, I can think of x squared, right? It looks like this. So that's an even function and positive, okay? And left and right is always the same. Left and right. At left side, x's go to negative infinity. On the right side, x's go to positive infinity. Now the value of the function, both sides, this function is facing up at both ends, so it means we're going to really big positive numbers. So on both sides, we're going to positive infinity. Okay, and then how many intercepts are there? Okay, we can count 1, 2, 3, 4 intercepts. Okay, let's go to question 4. 4 is fine. Actually, let's do 5. So let's go to question 5. So first question is degree. So we have x squared we have x and x, so there's 4 x's in total, so that's even degree. Okay, the leading coefficient is negative, right? So a is less than 0 and it's negative. Okay, even and negative, we can think of negative x squared, which would look like this. Okay, so end behavior is going to be going down, so left side is down and right side is down. Okay, now our x-intercepts are, you guys cannot skip this because a lot of people miss it. X squared means there's x-intercept 0, negative 2, I'm sorry, not negative 2, positive 2, and negative 1. Because remember, these are opposite. And 0 actually repeats twice. Okay? So I'm going to plot those on my coordinate plane. So we have negative 1, 0, and 2. Okay. And again, we know the left side and right side, both sides, the function is facing down. And because 0 repeats twice, at 0 we are not going to cross the x-axis. So I'm going to go up, turn, go to 0, come back up, and then go through 2. And that's the graph of our function. So I hope this helps everyone. Okay, and I'll see you tomorrow.